Okay, thank you very much for coming to my talk, even if it's your valuable lunch break. I really appreciate this. I will be talking about things I wish I knew when I started testing Spring Boot applications. So I would like to start with my introduction, my not so effective introduction to testing. So it was back then at university, I was studying business information technology, which is a mix of computer science and business. And quite late into my study program, we had a group project where we should develop a small Java application, a small game together. And one of the requirements to pass this class was to provide something in source test Java. So while we got the instructions, we were all happy. We were grouping our development team. We were eager to develop a nice game. And almost the night before we had to submit our small game written in Java, we rechecked all the requirements, and then we realized, oh, there's one requirement we didn't met yet, and this was testing. So almost doing an all-nighter, we tried to provide at least something. So at university, we learned about TCP/IP compiler, object-oriented programming with Java, but really nobody taught us what this testing is about. Our course instructor just mentioned we had to provide some tests. So what we did, we were Googling in the middle of the night with the goal just to pass this exam, and we were throwing JUnit into our project. Somehow wrote a test. I mean, the application was already done. It wasn't developed with testing in mind, so it was really a bumpy road. Also, our tests, we were just throwing annotations at them to prove. There are some classes in source test Java which somehow was enough for the instructor to pass the exam. And this was my first introduction to testing, so with really no guidance at all, and just a requirement to provide some tests. Somehow this journey continued for me. So when I started as a junior developer for my first job, I was super happy to join a team, set up everything, now use the knowledge I got from university and develop software. So we gathered around the Scrum board, everybody was introducing themselves, and I finally found a task which I could pick and work on. So being new to a team, and even if you're a junior coming from university, all the setup stuff is quite complex. You are happy once you can compile the project and start it locally. And then I found a task, a small task which I thought was doable in a day, and it turned out to was an entire week of development. So pain, sweat, and tear went into the first feature I was developing, and I was eager on Monday morning then to raise the PR, to show the team and to impress the developers in the team. I was capable of doing something on my own. And upon raising the pull request, I got an immediate rejection from one of the lead developers saying, the changes look good, but there are no tests. So I was super frustrated. I looked back into the Jira ticket, which says implement feature XYZ, and there was nothing about tests. So I thought maybe it's an afterthought, maybe we do it at the end of the sprint. So having no introduction to testing at all, it was really hard for me to understand it. What followed was another week of pain, sweat, and tear trying to get the testing right, asking other team members. They were just saying, look at the existing tests, try to do what they are doing, use them as a source of inspiration with a mix of cargo cult, and nobody was really knowing what they were doing. So this was really, for me, the introduction to testing. And with this talk, I at least want to give you now the guidance I wish I had when I started testing Spring Boot applications. So the technical building blocks about Spring Boot that, in my opinion, makes testing Spring Boot applications really joyful. So one of the goals of this talk is to lay your foundation for your success for testing Spring Boot applications. We'll do a short introduction to what I think is an excellent test support within Spring Boot. I will showcase a mix of pitfalls and best practices. So having this 40-minute lunch talk, I can't go into that detail. I also labeled it as beginner-friendly. So we will cover a lot of basics, but also at various points, hint to further advanced techniques and patterns. And last but not least, I want to convince you that testing is not an afterthought. And as you have seen with my journey, it was really a bumpy road to it. And I hope that not many developers need to go the same road. For the agenda, so we just covered the introduction. What follows is the main part. I picked 4 things I wish I knew when I started. So the first one is the testing Swiss Army knife. What follows is why the Spring Boot test annotation isn't always your friend. Next is slicing, a specific concept for testing Spring Boot applications. And finally, a more practical advice on using JUnit 4 and JUnit 5 in the same project. Afterwards, I give you some points on where you can go next, and we will close the talk with a conclusion and a Q&A. Some words about myself. So I'm Philipp. I'm a freelance IT consultant from Berlin, Germany. Besides the freelance work, I enjoy creating educational content on both my blog and on YouTube. Since 2 years, really with a focus on testing Java and specifically Spring Boot applications. I've also co-authored a book, Stratospheric, From Zero to Production with Spring Boot on AWS, where we showcase all the tools and the knowledge you need to bring your Spring Boot application to production on AWS using the CDK, using AWS ECS and all the surrounding monitoring and observability tools. Yeah, there are some links you can check out if you want to connect afterwards. But first, now let's get right into the first thing I wish I knew when I started. So I call this the testing Swiss Army knife. This is not the official term you will find in the Spring Boot documentation. Every Spring Boot project that you create, either within your IDE or at start.spring.io or any other form of bootstrapping a Spring Boot application, has this testing Swiss Army knife already with batteries included inside the project. What I'm referring to is the Spring Boot starter test. So the Spring Boot starter test is really a foundation for your entire test suite. So when starting your first Spring Boot project, there is really nothing to configure, no plugins to fiddle around, no configuration to change. This dependency that is part of every Spring Boot project, you can't even deselect it. So if you recall start.spring.io, where you can tick the boxes of which JDBC driver you want to include, there is no box that lets you deselect the Spring Boot starter test, which I think is a convenient default so that every new project has this starter. And this starter really brings all the basic testing libraries and frameworks for you to get started with testing Spring Boot applications. Let's take a look. If we run Maven dependency tree and analyze all the transitive dependency that gets pulled by this starter, we will see that's quite a lot. So there's JSON path, there's SRJ, there's Hamcrest, there's JUnit, Mockito, and many other testing libraries. We will take a short look at each of them in the next slides. Overall, it's an opinionated testing toolbox that the Spring Boot developers selected for us to be used at day one. So again, nothing to configure, no plugins, no research that needs to be made, and new developers can just start writing their tests. The benefit here is also that Spring Boot manages the dependency versions of these testing libraries, so they also ensure a basic compatibility between them, and we can really we don't need to take the driver's seat and managing dependencies. All of this will be managed by Spring Boot. And if you think why there's so much dependencies included, I just need 1 or 2 assertion libraries. There's also no need to exclude them, as they don't end up in your production jar, as they are scoped with tests. There you also won't pollute your production jar, and there's no need to exclude any of them. They are just there for you to be used. So let's take a quick look at each of them in detail. So the first and most important one that is part of this Spring Boot starter test, which is transitively then pulled, is JUnit. So JUnit in general is the core testing framework. There's also TestNG, and Spring Boot also supports TestNG as the testing framework, but over the years it seems that JUnit is really the de facto standard. It's a successor and rewrite of JUnit 4. With our last topic, we will also see that there are some caveats and some pitfalls if you mix the versions. JUnit is also more than just the test annotation, so you might have already written your first test and then annotated a method with the test annotation. There is way more to JUnit than just running your test. So JUnit comes with a rich extension model that lets you integrate with the framework. So with Spring extension, for example, you get the deep integration to the framework. You have test parallelization, so JUnit also provides configuration parameters to parallelize your test. There are dynamic tests, parameterized tests, so there's a lot to this framework, and yeah, it's really the basic testing foundation for our application. Next, Mockito is also part of this toolbox. Mockito is, I would say, currently Java's de facto standard mocking library. So when do you need mocking? You need mocking if you test a class which collaborates with other classes, and during the unit test, for example, you don't want to depend on the implementation of the other class, so you mock the collaborators, stop their behavior. So you tell, for this test, I now want to see how my code behaves if the collaborator throws an exception. And then also afterwards you can verify the interaction with those mocks. All of this is made possible with Mockito. Mockito also has a deep integration with JUnit Jupyter. So on top of this example test class, you see the Mockito extension and really a set of annotations and features of Mockito that you will use most of the time for your tests. What follows is SRJ. So while JUnit also comes with a set of assertions, there is also a library dedicated to assertions. SRJ comes with many matchers, not only for the primitive Java types, but also for collection and temporals. You can even write your own assertions with SRJ. And compared to the assert equals of JUnit Jupyter, it's also more fluent and sentence-like. So you have the assert that is equal to, and yeah, it gives you in general a more flexible approach than the assertion libraries of JUnit. Next, there's yet another assertion library that gets pulled by using the Spring Boot starter test, which is Hamcrest. So again, it's also more fluent. It looks similar to SRJ, has a little bit of difference in the syntax. It's also occasionally used in some APIs of Spring Tests. So for example, there are mock MVC methods where you can pass a matcher from Hamcrest. So occasionally you may need to pass a Hamcrest matcher. If you're coming from a different programming language, chances are high that you may have already worked with Hamcrest. So Hamcrest may be your go-to choice. But in general, now seeing 3 different assertion libraries, it's usually pick the one you feel most comfortable with. Don't mix, for example, Hamcrest and SRJ within the same test, because then it might get hard with the imports because both have the assert that. And usually, as a beginner, start maybe with the assertions from JUnit and then go from there. Another nice utility that is part is JSON assert. So JSON assert is also an assertion library dedicated to JSON data structures. So it lets you compare entire JSON data structures. There's not much features in JSON assert except these comparing of JSON objects. What you can do, you can separate between a strict and no strict assertion. So in this example, what you see on the slide, it's a no strict assertion. The last parameter is set to false. Strict means if the compared objects have to match with the real equality, or in this example, we are just interested that our actual JSON string has the name attribute in it. The final testing tool I quickly want to describe that is part of the toolbox. So as mentioned, all of the tools you just saw are now part of your Spring Boot project. You may not have even noticed this is now JSON Path. So JSON Path is, I wouldn't say it's a testing library, more than a utility. So if you have bigger or nested JSON objects and you want to just select a single attribute of it or do some computations, you can use JSON Path to write JSON Path expressions. In this example here, we are interested in the length of the text attribute, and can then use the result for our tests and use any assertion library that we want. One more note on Spring Boot dependency management. So while we have seen that we include the Spring Boot starter test without any version, similar to the many third-party libraries that the Spring Boot parent POM manages for us, there are also libraries that are or that can be managed by Spring Boot. So the libraries we just talked about, they are all managed by Spring Boot, so we don't have to take care to update them consequently. There are also some other examples. So if we introduce further testing libraries, for example, Avatility for testing asynchronous code, Selenium for writing tests that interact with the browser, or the mock web server, a tool to provide a local HTTP mock to test, for example, HTTP clients, we can, if we want, include them without a version. So the version internally is managed by Spring Boot. So in general, if there's a new dependency you want to include, you can first check the Spring Boot parent POM. Maybe Spring Boot already covers the version for this library for us.
Hold on. Is that explained?
Unplug?
No, it was okay. It was okay. It was okay.
Okay. Did it just happen?
Yeah.
Okay, thank you. Okay. So coming back, if we don't want to opt in for the Spring Boot dependency management, we can also always opt out. So if you're working with a legacy Spring Boot application where we can't upgrade the Spring Boot main version, but we want to take use of recent Mockito versions, for example, there is no need for us to exclude Mockito from the starter and then re-include it or put it into dependency management. The most simplest approach here is to just override a property and then manually specify the version, and then we will opt out of the managed version that Spring Boot would provide for us, and we are back in the driver's seat and can manage the library versions on our own. But then also have to ensure that there's basic compatibility between the tools, but in general, when it comes to testing tools, there is usually not much interference on a compatibility level, so we are usually fine up and downgrading the libraries, making sure that they work with the Java version we are using. So next is at Spring Boot test isn't always your friend. So speaking of things that get auto-generated by default for our test, for our project, apart from the Spring Boot starter test that we can't deselect, there's also a default test that gets generated with every new Spring Boot project. It usually looks similar to this. So we have the add Spring Boot test annotation on top of our test class, and then a basic test without any assertions, which ensures that the context loads. So what this annotation or what this test will do, it will try to assemble our entire application context, make sure all the beans load and all the configuration matches, and in general there's no issue with starting our application. The problem now is, or what I've seen in project and also many times on Stack Overflow, is that many developers that are new to Spring Boot, they see this annotation as the go-to annotation. It has Spring Boot in the name, so it must be used anytime for every test that I'm writing. And why this is not a good idea, we will discuss this now, but first let's try to understand a little bit more in detail what this annotation does and what it is used for. So with the add Spring Boot test annotation on top of our class, what Spring Boot will do, it will try to find our main Spring Boot application class and then populate the entire application context. So on the right you see a sample application context, a lot of beans, all those circles are Java classes that gets populated into our context. Also, when starting our context, depending on how big the project is and how many things we integrate, we need to provide surrounding infrastructure. So if we are connecting to a database or to a messaging queue or are doing any HTTP calls on application startup, all those tools need to be provided during the test run. So if they are not there, if the database is not there, this test will fail because the JDBC connection pool can't be created. So in general, this annotation is really best suited for writing integration tests and also requires some effort depending on how big the project is, as we have to provide all the infrastructure components that our application connects to make sure that our application starts. Also, there's a small difference on how to use the annotation. So if we use it without any further configuration, Spring Boot won't start our servlet container. So if we are writing a small web application that exposes REST APIs, If we are using the annotation as is, we were still testing with a mocked servlet environment and then use mock MVC to interact with the servlet. So there won't be any there won't be any port occupied on our machine. So when writing such a test, no real HTTP communication will take place. And the opposite is if we really want also to start our embedded servlet container, so let Tomcat start, then we have to override the default web environment and either use a random port, which makes sense if we have multiple contexts to be started so that there is no port conflict. Only then will Spring Boot start the embedded servlet container, and then the port will be occupied, and then we can make real HTTP communication to the endpoints of our application. So now the problem, or I call it also the at Spring Boot test obsession. So many new developers are seeing this annotation and then they try to forcefully use this annotation for all the tests they are writing. And if they now want to write a unit test, so to say, for a single service, they want to really isolate a service and want to test all the branches, all their loops with all the different outcomes of the surrounding collaborators. What they now do, they will use @mockbean, and with the @mockbean annotation, we are replacing a bean inside our context with a mocked version of it. The developers, or those that do it, they need to do it because they want to test, in this example you see here, the surrounding collaborators of this class are now mocked, so during the test they can then use Mockito to test the various outcomes of the collaborators. And really misuse an annotation because, as you see, they are only interested in testing the service class, while Spring Boot takes the entire effort to boot everything. So the web layer is initialized, your data repositories are initialized, while you were only interested in testing a single part of your application really in isolation. So you can compare it to testing the car of your door. To test the car of your door, you don't need to start the engine, and because starting the engine, you need to ensure that there is your battery is loaded and that there is gas in the tank. That's really not necessary if you want to test something in isolation. And using this approach, or seeing just this at Spring Boot test annotation, really also then results in longer feedback loops, because starting the entire application context for a small Hello World project may be in a sub-second time, but having bigger projects where there's a lot of initialization during the bootstrap phase, all of these different tests need to start their own application context because they vary in the context setup they are using. Because under the hood, Spring Test can actually cache an already started application context. So if the context configuration for one test, for example, that uses end Spring Boot test, has the exact same configuration, then Spring Boot can reuse this context for a subsequent test, making your test suite way faster because the context doesn't need to be started over and over again. But the problem is we can't make use of this context reuse feature if we are using this at Spring Boot test annotation all the time, providing many different versions of our application context for testing purposes. And in this example here, applying this pattern throughout all our application, really slowing down our test suite because each of these tests requires an independent application context starts, which takes time and also lowers our feedback loop. And in general, when seeing such things, there's usually a better approach here would have been to write a plain old unit test with just JUnit and Mockito. No need to start an application context because this can be an expensive operation depending on how big the application is, and usually then you need to do a lot of workarounds to get your unit test working while you have to mock all the surroundings with mockbean. So when at Spring Boot test is not sufficient, or there's also another concept we can rely on, which is slicing. So having the one way of writing the test with everything being loaded, we also have the pattern or the technique with Spring Boot to just load a slice for our testing purposes. And coming back here to our sample application context, seeing now here some boundaries between our beans, actually it would be quite nice if we are interested in testing our web layer with a test. Why can't we just load the web layer related beans into the application context for testing purposes? When testing our web layer, for example, making sure our theme leaf template renders, we are actually not interested in any data repository or any HTTP client or any service that is laying around. We are only interested into the web components. And this is what Spring Boot gives us. So there are many Spring Boot test slice annotation that lets us achieve exactly this, so that we can isolate a specific slice of our application. There are predefined slices that we can use out of the box, and even write our own Spring Boot test slice to only populate a subset of our entire application context, making the context for testing purposes really small by neglecting what's in a layer below. So to demonstrate this, let's use the web layer as an example. So for our web layer, there is support for almost every technique we can use to write our web layer. So there's @webMVC test. If we are writing a servlet-based application, there is webflux test. If we are writing the reactive counterpart, and also recently @GraphQL test. And what this annotation will do, so internally Spring Boot will then only auto-configure those beans that are relevant for testing our web layer. So when testing the web layer, we are interested for sure in the controller. We are interested in any filter or converters that we have configured. And even we are interested, if we are using Spring Security, into our security configuration. So Spring will take the effort to only pick those beans that make sense for testing this part of our application, to then have a much more narrow application context, which starts way faster and is way more easy for us to handle, because in this example, we don't need to take any effort to provide the database because no repositories are being populated. Still, we have to mock something, so we have to define, as our controller usually communicates with another collaborator in a layer below, what to do with it. We can either provide the real implementation, but in general, yeah, we will be using @mockbean to then mock any communication to a layer below, and having full control of our web layer. And in this example, also have HTTP semantics, because if we would write a plain old unit test invoking the controller method on our own, there is very little for us to verify. We can for sure verify that the response type of our method is the one we expect, but anything further down the line, for example, validating the input, making sure our authentication and authorization is working properly, we can't achieve this with a plain old unit test, whereas with this approach, we have way more techniques to ensure that our web layer is working. So a sample test to see what's going on. If we now use @webMVC test, we want to test a controller, we can use this annotation to pass the controller we want to test. So there are two modes to it. If we don't pass the controller as part of the annotation, Spring will try to load all our controllers, where we have then to also ensure that all the services of all the controllers are populated. If we are just interested in testing one controller, we can pass the name of the controller that we want to test. By default, Spring Boot will then also auto-configure this mocked servlet environment that we can use to communicate and send and receive mocked servlet requests and responses. We then, in this example, there's only one collaborator that we need to use mockbean, so we replace the service, because Spring won't also take any efforts to auto-configure the service for us, so that's why we have to provide mock here. And then we can use this mock MVC instance to communicate with this mocked servlet environment. And the benefit here is that we can make use of real, these are not real HTTP requests, but we can follow the HTTP semantics, post here in this example a mocked HTTP post request, use a content type of us, so we can also make sure if we have an endpoint that does a lot of content negotiation that the correct endpoint is called, our input gets properly serialized. If we have custom validation rules, all of these will be also checked with this test, while if we would have written just the plain old unit test without any context support, this wouldn't be possible. And then also as part of the response at the bottom here, with this mock MVC, we can have a fluent request setup and also a response verification, so we can ensure what HTTP status code is returned from our controller. We can check any headers that are being returned, or if we are using timely, for example, check the model and have really deep insights into how our controller operates, and can even integrate it, or as it's integrated with Spring Security, we can also test our authentication and authorization. So if we have an endpoint that is only allowed for users that have, for example, the admin role, there are tools in place to make sure that unauthenticated users are not able to access our endpoints. And when it comes to these at Spring Boot, or these Spring Boot test slice annotations, there are quite a lot. So depending on which tech stack you are using, it makes sense to check the Spring Boot documentation. There's usually for all of these default test slices a good part in the documentation that explains what gets auto-configured and where to use it. So usually for all the common storage tools for your data layer, there is a test slice annotation that lets you only populate, for example, if you're using JDBC, only populate your data repositories in combination with a data source and testing, for example, your native SQL queries. The last thing is a more practical or advice or recommendation, or where at least I stumbled upon when I started testing quite often, and also when answering questions on Stack Overflow, see that this is most of the time the root of any problem when setting up the tests and getting the context set up correct and also the configuration for your test. I call it the JUnit 4 versus JUnit 5 pitfall. For theoretical background knowledge, so JUnit 5 is a redesign of JUnit 4 and the successor and next generation of this major Java testing framework. Its first release was in 2017, so 5 years ago, and still there are a lot of projects. I mean, the technical debt is everywhere, but fixing technical debt in your source test Java folder is also less likely to be prioritized, so there are still a lot of tests being written or being maintained with JUnit 4. When talking about JUnit 5, actually we are talking about 3 modules. So JUnit 5 itself is a mix, or is a combination of the JUnit platform with the foundation and the test engine API. Then JUnit Jupyter, this is the new programming model, so the extension you saw, all of this is part of JUnit Jupyter. And then last but not least, the JUnit Vintage engine, which lets us run JUnit 3 and JUnit 5 tests next to JUnit 4. The problem I now see various times is that developers, while not being aware of the version change and the backward compatibility that is not there, they try to mix concepts, or when trying to copy-paste stuff from the internet or looking at older code bases for a source of inspiration, they copy over parts of JUnit 4 and try to apply them within JUnit 5, while in the end it won't work, as there is no real backwards compatibility between the versions. What is possible if one test is only using a specific version of JUnit 4 or JUnit 5, they can work perfectly fine next to each other, but within one test we really have to make sure we are using one version of JUnit. There's also automatic migration support. Just as a side note, we can use, for example, Open Rewrite. They have a Maven plugin which helps us migrate away from JUnit 4 to JUnit 5. But as a general overview, or at least that you have some indicators to differentiate the version, which helps you if you try to apply, if your context setup gets complex or you want to apply something from a previous project. Here's a short overview of the different annotations or the concepts. So it's quite hard to differentiate the test annotations. So if you have both JUnit 4 and 5 on the class path, you're in a rush. You just import the first suggestion from IntelliJ. You may end up in weird test outcomes because your test annotation is coming from JUnit 4 while you were using JUnit 5 concept. So I've been in this rabbit hole quite often, and then checking the imports really helped me fix the problem. So here the recommendation is to be aware of the changes, and then if you see something for JUnit 4 and want to apply it for JUnit 5, look at what the succeeding technique is for this version. Some words for you on where to go next. So I don't know your tech stack. So in general, as you now saw, a short introduction to this sliced test context annotations. Take a look at the Spring Boot documentation, find those test context annotations that fit your use case, fit your tech stack, and get used to them. Also quite helpful, align the test strategy and vocabulary in your project. So when I come to a new project, and I usually ask, how do you define unit, integration, and end-to-end tests? Because if there is no clear definition among the team, there may be a lot of confusion because everybody has their own definition, and it might get hard to align on the terms. Also, what helped me a lot is, if you're new to Spring Boot, you might just mark it as there's a lot of magic going on, but if you really take the time to understand the auto configuration, the convenient defaults, and what's behind Spring Boot's auto configuration, this will also help you a lot when writing your tests, because you then better understand what Spring Boot auto generates for us, and where it helps us. If you want, you can give test-driven development a try. So I'm not a strong advocate for it, but I've seen a lot of benefits while using it. But for me, it really made sense once I understood the tooling. So if you don't understand the tooling, if you don't understand Spring Boot, and then if you're new and want to mix everything right from day one, it might be too complicated. But the more you're into the testing tools, you understand your toolbox, the more you can also try other methodologies of writing your source code. And overall, what always helps is to be sufficient in the basic testing tools. So JUnit 5 and Mockito is usually the place where I would start with learning how to write tests. Actually, there's way more in the Java testing ecosystem I didn't have time to talk about. So if you're more advanced, take a look at test containers, which lets you manage Docker containers for your integration tests. WireMock is yet another nice tool to stop HTTP responses, and also Selenide, which is a small abstraction on top of Selenium that lets you write your end-to-end tests really with ease. If you want a more guided introduction into testing Spring Boot applications, I'm running a 10 hours hands-on video content on my site where I really showcase the entire tech stack. I'm using a modern Spring Boot application with a microservice approach, which should match most of today's microservices. And there I showcase the various techniques, pitfalls, how to do unit integration and end-to-end testing with Spring Boot, understanding what goes on under the hood, and really using real-world examples, because there is no benefit in learning how to write a unit test for a calculator and then coming to a project where you have message listeners, you have auth to log in, and much more. And that's where I try to teach at least the techniques that really help testing Spring Boot applications. Now, as a conclusion, you should have seen now, based on the testing toolbox, there's already a lot of excellent test support available for us to be used right from day one. So we don't have to wrap our head around finding the correct tools. We can use what Spring Boot already provides for us. We have this fundamental testing toolbox that is part of every project. In general, when writing our tests, we should ask ourselves, for this test, do I really need to start the entire context? Can I work with a sliced context, or is also a plain old unit test sufficient for verifying the implementation for this test? In general, this add Spring Boot test annotation is usually suited for entire integration test where you want to test your application as a whole. Don't misuse it and become obsessed by only knowing this annotation. There are way more sliced context annotation that actually can make more sense. Yes. And also the last practical thing, especially when you're new or when checking Stack Overflow, you might find a lot of JUnit 4 references, and then blindly copy and pasting it to your JUnit 5 project. You will not come to the desired end, and therefore be aware of the version change and check what you're about to copy. And in general, have fun writing your tests. So I see that many developers struggle with this, but if you take the time to also, apart from learning your programming tools with Spring Boot, also take some time to invest some learning effort into the tools and understand what's going on behind it, it really can become joyful to test your Spring Boot applications. That's it for the talk. The slides will be uploaded. The best way to reach out to me is Twitter. Check my blog if you want to see more testing tutorials and hands-on practices for Spring Boot application. And yeah, I can only then wish you a nice DevOps 2022 in Belgium.